In this video, let us continue to solve problems based on general solution of the equations reducible to the forms sine theta equal to sine alpha, cos theta equal to cos alpha, and tan theta equal to tan alpha. Alright, here we've got a question then which says solve sine 2 theta plus cos theta equal to 0. So what we're going to try to do as far as this trigonometric equation is concerned is we're going to try and transform this into one of the forms, say either sine theta equal to sine alpha or cos theta equal to cos alpha or tan theta equal to tan alpha. So in this case, we're going to convert it to cos theta equal to cos alpha. Alright, so we've got cos theta as equal to minus sine 2 theta, right? We just push the sine 2 theta to the right hand side. Now, minus sine 2 theta can be written as cos theta. Now, you write the left hand side as it is. Cos theta equals cos of pi by 2 plus 2 theta. Now, this is cos of 90 degrees plus theta. Now, cos of 90 plus theta lies in the second quadrant, and you know that it does not belong to cos. The cos is negative in the second quadrant. Plus it's a 90 degrees. So if you go back to the allied angles, you'll understand why cos of 90 plus 2 theta, or basically cos of 90 plus theta equals minus sine theta. So minus sine of 2 theta can be written as cos of pi by 2 plus 2 theta. Alright, so now we've reduced this, or we've transformed this equation to this form, which is cos theta equal to cos alpha form. Now the general solution of this equals is nothing but theta equals 2n pi plus or minus alpha, right? Alpha is nothing but the angle here. So plus or minus pi by 2 plus 2 theta, most importantly in brackets, where n belongs to z, or n is an integer. But if you're thinking it's done now, no, the problem isn't done yet. We need to go further, and then, there is plus or minus. So we need to solve for both positive and negative individually. And let us start doing for positive. Now, taking positive sign, let us see what do we get. All right. So we get theta equals 2n pi plus, opening the bracket, we have pi by 2 plus 2 theta. And then let's group the thetas together. Let's take 2 theta to the left hand side. It becomes theta minus 2 theta equals 2n pi plus pi by 2. So minus theta equals 2n pi plus pi by 2, right? Or theta equals, multiplying both sides by negative, we get theta equals minus 2n pi minus pi by 2, or theta equals 2m pi. Well, don't wonder what's happening here. I'll just tell you the end of this step. 2m pi minus pi by 2, where m equals negative n, and that belongs to integer. All right, so that is what, just replace m by negative n, you get this. It's just to write the equation in that form, the general solution. So the general solution, when we take a positive sign, we have theta equals 2m pi minus pi by 2, most importantly where m equals negative n, that belongs to integer, or that is an integer. All right, so now we're done with one part of taking the positive sign. Now the next thing is to take the negative sign and see what happens. What is the general solution that we get? So taking the negative sign, we have theta equals 2n pi minus of pi by 2 plus 2 theta. Since it's negative sign, we straight away can't remove the bracket, so we need to convert it. So we have, take the negative inside. So we have theta equals 2n pi, minus of pi by 2 is minus pi by 2, and minus of positive 2 theta is minus 2 theta. So shifting negative 2 theta to the right hand side, we get theta plus 2 theta equals 2n pi minus pi by 2. So we have 3 theta equals 2n pi minus pi by 2. Or we have theta equals 2n pi divided by 3 minus pi by 2 times 3 is 6, where n is an integer. Alright, so this is the general solution. This is another general solution of the given trigonometric equation along with this one here. Alright, so that ends this problem. Now the only difference between the previous problems and this is, here we are not stopping here. We are splitting it. We are, seeing what happens when you take only the positive sign. We are also seeing what happens when you take only the negative sign. So that's the major difference between the previous problem and this problem. Alright, so that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on general solution of the equations reducible to the forms sine theta equal to sine alpha, or cos theta equal to cos alpha, or tan theta equal to tan alpha.